All right, so let's begin our notes on atomic structure. All right, so this is a very important unit for the year. We're going to build on this the whole rest of the year. So it's really important that we get the basic foundations laid out. So what is an atom? So an atom is the fundamental building block that makes up all matter. So all matter consists of atoms, right? And then that's a symbol that we've seen, Big Bang Theory, other things, right? That's kind of how we've symbolized chemistry and matter. So that is a model of an atom. So we have, as far back as the ancient Greeks, we have Democritus, who comes up with our first real model of the atom, a representation of what an atom is. So he's a Greek philosopher, and he came up with this idea of the atom using his senses and observing things around him. So he was one of those ancient Greek philosophers, such as Aristotle and Socrates. So he has a discontinuous theory of matter where atoms are small and indestructible particles, and the word atomos is where the word atom comes from, which means indivisible. So you might not be able to see that underneath my screen sharing icon. So after some time, we have now moved on, and now we have a new model of the atom presented by a chemist named John Dalton. So Dalton was an English scientist, and he used Democritus' ideas to form an atomic theory through experimental methods. So beyond just the philosophers who, experimented through thoughts and logic and reasoning, we have actual physical experimentation done. So Dalton has some important points to his theory. His first important point, and these are called Dalton's postulates. So all elements are composed of tiny indivisible particles called atoms. All right, so atoms, let me get my little pen icon going here. All right, so atoms, right? So we've seen that before. Atoms of the same element are identical. The atoms of any one element are different from those of any other element. So elements are made up of atoms, right? So then if I have a sample of gold, right? So gold is AU. So if I have a sample of gold, or if I have a sample of silver, right, which is Ag, or maybe even a sample of copper or of iron, or maybe I have a sample of oxygen, all of the atoms in gold are identical to each other. All of the atoms in a silver block are all identical to each other. And every molecule, every little atom of oxygen is identical to other oxygens, right? They have each individual properties. Atoms of different elements can physically mix together, or they can chemically combine in a simple whole number ratio to form compounds. So I can physically mix gold and copper or anything, right? We can take a mixture of metals. A mixture of metals is called an alloy. But what we really want to get in here is that combine chemically in simple whole number ratios. So let's take a compound we all know, water. So water combines in a whole number ratio. I have 2 hydrogens to 1 oxygen. It's a whole number ratio. Chemical reactions occur when atoms are separated, joined, or rearranged. Atoms of one element are never changed into atoms of another element as the result of a chemical reaction. So that means I cannot change gold. So what he means is gold cannot be changed into silver. Silver cannot be changed into gold. So this is one of those things that the ancient philosophers or the ancient alchemists were trying to do, right? Convert base metals, right, or cheap metals such as lead or tin, and convert those into gold. And that wraps up our first set of historical scientists, the model of the atom. And our next video lesson, we'll talk about J.J. Thomson.